So again, we are middle of figuring out this probability question. That is if a person cuts the cake two separate times, and we want to know what is the probability that this customer should get somewhere between 1.99 pounds and 2.01 pounds. So let's first find out the distribution of this. Distribution means that we have here a random variable called z, that's x plus y. X is a random variable that can take any value between 0.0975 again, we said that if it's 2 pounds, it can go from 1.95 to 2.05. So if it's 1 pound, it's 0.0975. That is 0.0 and that is can go all the way till 1.025. So it's 0.025 more than a pound, or 0.025 less than a pound. I'm sorry, I said 0.09. It's 0.975. 0.975. Okay. From 0.975 till 1.025. So the way how to do it is like this. I'll take a pen and show it. Okay, here I made a drawing. X goes from 0.975 to 1.025. That is the first cake, and Y also has the same uniform distribution. So our question was the probability that X plus Y should be in between 1.9 and 2.1. .99 and 2.01. In the first case scenario, we had 1.95 to 2.05. I'll write it down here, 1.95 to 2.05, and then we realized that 1.99 to 2.01, that is 20%. (1.95 to 2.05), that's where the error goes. So the question is what the probability should be anywhere from 1.99 to 2.01. The answer is that is 20%. And that means that there's 80% chance that should be out of this range. Let's see here, the probability should be from 1.99 to 2.01. So first of all, we have to know on the graph at which points is x plus y less than 1.99. Actually, exactly 1.99. Let's first do like this. So this is going to be the x plus y is equal to 1.99. So we do like this. 1.99 so we start 0.975. Okay, take a look at this picture. That area there, that diamond-shaped area, that is the area where it's between 1.95 and 2.05. Making it close to the screen, you see x plus y is equal to 1.99, and the other line represents x plus y is equal to 2.01. Anywhere between these lines, x plus y is between 1.99 and 2.01. Now it's just simple geometry to see the area of this trapezoid, you may call it. So let's do the math. The way we'll do it is, from the full square, we'll deduct the triangle, so we'll see how much is left over. We will deduct, the easy way to do it is to deduct the top triangle and the bottom triangle, and then we know how much is left over in that strip. So since y is 0.975, and to get from 0.975 to 1.99, so we do 1.99 minus 0.975, and we get 1.015. Showing it here. This is the point where that line touches the x-axis by 1.05. Why? Because this is if x is 1.05, if y is 0.975 and x is 1.015, it adds up to x plus y is equal to 1.99. So in other words, this triangle goes from 0.975 to 1.015. How much is that? So we just do simple math. It's 0.015 plus 0.025. That equals 2.040. .015 plus 0.025 is 0.040. That is the measure of this line from here to here. All the way. That is 0.04. So if you realize that this is 0.040 and the other side is self-understood the same thing, so we have here a square that has the area of 0.040 times 0.04, that is 0.0016. What is the area of the full square? It's 0.025 from both sides. So it's 0.05 times 0.05, that's 0.0025. So the difference between 0.0025 and 0.0016 is 0.00. Actually, we're interested now to know the percent. So what is the percent of 16 over 25? That is how much it will be out of the range of the 1.99 and 2.01, and 9/25 will be in the range. So 9/25 we all know is more than 20%. 20% is would be 5/25. So we see we got here almost double, because we sliced the cake twice. We got almost double the probability that we should have it in the range between 1.99 and 2.01. I hope you understood this video. I was a little bit unclear, but again, the idea is that you find out the full probability distribution when it's done with x plus y. Then you'll see that it gets a bigger range that in the area between 1.99 and 2.01. You get 9/25 of it in that range. Thank you for listening.